now. All right. So we'll be loading some Google Colabs from the GitHub repo. You don't have to do much to actually do that, right? So come here to file and so say open notebook and you can come to GitHub, right? So you point, I mean, this repository is open. Once you point interest to, you type it. It's in my account actually, right? So once you type that here, you will select the African AI Foundation repository, and you will see all the notebooks, right? You see all the notebooks. So most of the notebooks are what we'll be using for the generative AI series. So let me just open one of them and let's play. So today's class will be more of play. Let's play around and even understand what generative AI is all about. I don't have a ready deck. It was a very tough week. I couldn't get to it, right? But I have a few things here and there that I will just show us. All right. Generative AI. In the second series, Dr. Tulu took us through several, areas in machine learning where you are using, you build a model that tells whether something is, it classifies, right? Whether something is, right? When it comes to those images and then try to do some sort of classification, right? The thing there is that for them to be able to tell this type of dog, I can't remember the name of the dogs that did, but I recall clearly that some of us were dogs were looking like the actual right. But the point is, if a machine could tell dog is in a picture, but after you've trained it, the machine should also be able to generate that kind of dog. That's the concept, right? So it's a sort of like a review of that process of you know uh classification. It's a reverse of classification. I can say that. So if you train an AI model to understand dogs and all these things, and image, it tells you, okay, this is a cat, this is a dog, or this is a type of cat, or this is a type of dog. In that process of it, it understands about the world that makes it know that this is a cat or this is a dog. Essentially, that's right. That's the whole bottom line. Now, when we want to generate a new, we are checking the machine learning model of what it knows to be a cat or a dog to generate a new one, to generate new ideas and dogs for us. So that's the concept of, that's the concept of generative AI for the most part, right? And this is applicable to, images, is applicable audio, is applicable anything at all, because convert those data sets to convert them to the data set, whole concept will still work, right? So let me show you. I have a picture that I think describes. All right. This picture. So you have an AI model that has been trained with this image, right? It has been trained with these images. The process of training, entail. If you've used Midjourney, how many of you have used Midjourney before? Have you used Midjourney before? Can I hear hi or type something in the chat room? I've Midjourney I know they've stopped free trial. They don't free trial, but did you get to use it before they was used models before?
No,
You
sir.
didn't?
No, no, not yet.
Wow, that's really surprising. Okay, okay, that will be the right place started then. That will be the right place started. We did a demo of uh DAL-E. We were, going through some of these. Let me see. Oh, I still have some credits. Okay, let's get login. If you recall, there was a time we did, that I think that should be class 4, where we ran through all various types of models, how they, on Open AI, and like, let's see. Um, this is DAO-E, create realities, and from a description. So, are you logged in? I think so. Hmm. Here let me see. I think I should still have some credit. We have some credit there. So, let's say the picture uh, of an astro riding a horse. Always miss the spelling. All the, okay. This is going to generate this for us. These were, images we generated the last time. Okay. Not bad. Not bad. But it gets the concept. So, how is an AI able to generate this image, right? It probably was trained with this image, but it knows what astronaut is, it knows what a horse is, right? And what right horse means, and it's able to generate image. So that's what we are talking about here. So in the next class, that in terms of building models, and this is actually the part that involves some of the uh expensive GPUs to train, but we'll get there shortly. So let's just play around. So yeah, I was explaining the process, right? So yeah, that's in this Google Colab, this guy saying train their data set is Lion 5B, right? If you want to check out the data set, you can click this link, right? And let's follow to the data set. So this is our sample data set here. We are using sprites, images, right? To train an AI model. And at the end of the day, its idea look like this, exactly the point, right? So let's take it. Yeah, okay. That's it. So let me Hugging Face. The rest is pretty simple. It's just images. Hold on. Yeah. Let's look at this version data set. All right. So this is what the data set looks like. All right. Take a look at one of these. A lot of this. Of a house, a room, right? And then move on to the data set is probably, just random ideas. Random ideas. This is what the data set looks like. So this is quite just random images from the internet. Uh, okay. I'm trying to remove the first quote in front. Finally, we're there. Okay. So what do we have? I think my isn't all that great. Hi.
Hello, sir. Well done, sir. Please, I just want to ask, how can one locate this file from? Is it on the Google Colab that we can locate it, or because I'm trying to search for it and I've not been able to get it, so that one will
Okay.
be able to follow up.
I'm dropping the link right. I'm dropping the link right now. To the right, link to the GitHub. Currently, the beautiful bride. Amazing, amazing. This is what the next, row. That's what it looks like. And see the word embedding. This is the text that goes in that set. That image, Gunley's Island wedding photo, right? So you can see it has an accompanying text. Amazon registry wedding gift. We check everything, but look at this. Hi. Right. Hold on. Let me change my network. Can you from my end? Can someone else change my network? Too bad. Okay. Sorry. Let me change. Can you hear me now? Is it better now?
Yes, it's much better. Thank you.
So sorry. Yeah, I see. I'm still in Niger. We didn't experience this when Dr. Tulu was taking us through this series because it's probably using the fiber, right? Okay, fantastic. So I just changed my network. Wow. So you guys must have missed a lot. Let me try to backtrack a little bit. Let me backtrack a little bit. So I took us through the GitHub repo, the African AI Foundation GitHub repo that we'll be using for this generative series. And I dropped the link to that repository uh, on the group chat. Let me do that again. So that's the link, right? So you can just click it to follow that to the repository. So we want to, brush on diffusion models today, and then talk about just get a general grasp of what these models do and how they work, right? So I opened up this notebook right here, this notebook right there, Stable Diffusion. That's one of the AI models that is able to generate images. It's just one. There are a lot of them. There are a whole lot of them out there. So, um, so when we opened it, this is it right here, opened. That was taking us through the data set that was trained on. I. Oh, damn it. Sorry, Nyolua. Sorry, everyone. It's kind of like clumsy a little bit. I forgot I wasn't sharing my screen. Now I'm sharing it. Okay. Yeah. So I took us through the GitHub, opened up this stable diffusion. Let me open it up again. So this is how to open up a notebook from GitHub. So if you have a fresh collab, if you open up a fresh collab, let me cancel this. You come to file and you come to open notebook and you come to GitHub and then type the GitHub account you want to load the notebook from, right? So that the account is unique. That's my GitHub. And then you will find from other repositories, you see this African AI Foundation repository. Just click it and then you'll be able to load all the notebooks that we have in there. And then now open this stable diffusion notebook and it's going to open up right there. So that's the step how to open up a notebook from GitHub. So the this notebook is telling us the training data sets for this model. So it's trained on a lot of 512 by 512 images from a subset of Lion 5Bs. This data set contains 5 billion images. It contains 5 billion images, and we were going through some of those images. We opened up a few of them. Let's see. Let's open up this. So these are the images Stable Diffusion is trained on, right? So mixed and mixes. Okay, so they say is a registry what? Amazon registry best wedding gift items. This thing is so interesting, it's so useful, the text, because that is what is paired to the image when the AI model is learning, such that if you type an idea of, let's say, you say registry gift, plus some other ideas that it knows what it look like, it can create a unique image, by combining concepts from the two images, right? Remember, at the end of the day, everything is numbers, right? So for the computer to add up numbers or multiply numbers or do vector addition in technical terms, it's called vector manipulation. When we were in secondary school, there's this vector mathematics that we used to do. We used to do two-dimensional vectors, three-dimensional vectors, but it's kind of like a little bit complicated here because the vectors are higher dimensional. A whole lot of dimensions are involved here. But it's the same mathematics at the end of the day. You're changing the mathematics there. So I can say that I can bring idea from Houston, Texans, Stripend, wedding gift items, and then it's going to combine ideas it has learned from these and these together to print out a new image. So that's why diffusion models, every image it creates are always unique. right? So these texts are what tells it to, it embeds this text as part of the learning from each of the image it's trained on. That's the best way to put it, such that by the time you say that, okay, give me a blonde hair, African. I mean, that probably never exists, right? But it knows what blonde hair looks like because it's contained in the data set. It knows what African, skin looks like. Then it can combine those two ideas and generate a new image, right? So that's how it works. So I took us through an example of a generative AI model. Let's see, a blonde hair African woman. See what it comes up with. Okay, not bad. It's kind of okay. Let's say realistic. Um, we don't want a cartoon. Well, it probably it's probably not contained in the data set, but at least the concept is still there. The blonde hair and the dark skin and all that. Yeah. So that is what it looks like. And to run this, I'm connected to I have GPU connected on my Google Colab. We've never used GPU because we've never needed it, right? But you should be able to run this fairly, it runs fairly okay on a CPU based Google Colab as well. So this is the time that would now be setting up all those resources that we mentioned, at the American corner, so that you can now practice, you know, uh, with a GPU connected Google Colab, because the amount of computation needed is pretty huge. So this command is a command to check, the GPU that is connected to your Google Colab. Is just to see, right? So then we have to install a few things. We install diffusers, and I'll explain shortly. Mr. Samuel, I explained how to get a link. Are you unable to get it? Can we access the link? Let me get. Can we access the link to the current Google Colab I'm on? Okay, network issue. Not a problem. Let me know if you still cannot, or let me see. I think I should be able to see if this direct link works. Check this out. I've already loaded it. Try this direct link. All right. So we have to install a few things. Diffuser model. I would explain the broad idea of diffuser model this week, and then get deeper into what is happening in diffuser model, next week. So diffuser is the Python library that allows you to be able to interact with the diffuser model, and then transformer. I would explain the surface level of what's in a transformer model also this week, and then get into the detail next week. So this is just for us to be able to understand what's going on with all these things, right? So we have a bunch of diffusion models available to us. We're just going to be using. Okay, the link works for you. Okay, fine. Fantastic. Awesome. All right. So this notebook has a lot of text that you can go through at your leisure to fully understand what is going on and why we're doing everything that we're doing. You know, so now I'm trying to load a particular model. This is the model right here that's been pre-trained by, let's see. All right, so this is the model. This is the model right here. Okay. So who owns it? Comvis. Comvis owns the model. They have a whole lot of, um, a lot of generative AI models on their repository. By the way, Kaggle now has models as well, so you can, similarly the way you're accessing models from here, you could, load them from Kaggle as well, if they make it open. By the way. So yeah, so this is the model we want to use. So this is telling us that we optionally can use any of these models as well. This is a model from Runway ML. Runway ML is very popular for generating, they've gone so far in terms of, video generation. Very soon, we are anticipating that the budget for making a new movie would crash down to maybe $500 from maybe $5 million or $1 billion that it currently is. It should get down to maybe $500 or maybe a few $1,000s, right? And there won't be director going to see what do they call it? Is it to location, right? And all the gathering all those people. In the nearest future, an AI model will be able to real time generate a video of a particular story and entertain you real time. A story that probably never existed, that someone just, of course, I mean, all the movies you're watching is just someone's script, someone's story, right? So that's where all this will be getting into. And Runway ML has started, you know, going forward in that direction. If you check out their repository on GitHub, sorry, on Google, on Hugging Face. Sorry, let me. You'll see a lot of fantastic models that's about video generation, image generation, and things like that. Check them out on Twitter as well. Very interesting stuff they are up to. Runway ML. Fantastic guys. Oh, it's like they've closed sourced a lot of their models. Okay, now because they started charging on their platform, you can check them out here. Runway ML. You can check changed the closed source a bunch of their models. Very interesting. Check them out on YouTube as well. You'll see a lot of things that they've done with their AI model. This is an explanation video done by AI, end to end, end to end. See how it's looking like you know, it's looking pretty, right? High quality cinematography. Yeah. All these videos are not real. They are generated by AI. So imagine the application of this in education. Imagine the application of this in entertainment and all of those, right? So yeah, I think they've closed sourced some of their models based on what we're looking at here. So let's go on and continue using our image generative model. So stable diffusion, we installed diffusers up here, and I think it's done, right? We installed diffusers, and from diffusers, we imported stable diffusion pipeline. Stable diffusion is one of the modules in diffusers. They have a bunch of them. And then from stable diffusion, it's stable diffusion pipeline from pre-trained and then pass the model name, right? And then this particular uh, parameter tells the model, how much accuracy Remember, a model is just a bunch of numbers, right? Across the layers of the neural network. So a 32-bit floating type number will take 4 bytes. So it will be heavier to process an inference. It will take longer time. So now we passed float type 16 here. So we're saying that, you know what, for the sake of generating the image real quick in time, reduce the accuracy. Maybe the picture quality will now be a little bit, poorer that if it's 32, float 32, right? That's what this is simply doing, sacrificing speed for quality essentially. So let's run this. Okay, so it's loading this model from Hugging Face up. It's loading the model. Let's wait for it. Should be done anytime. Wow. Okay, not bad. All right. While this is loading, let's check more of the data available in the data type. I mean, data sets used. By the way, you can actually come here and, you know, do a few inference as well. Let's see. Um, okay, let's turn it off. Let's use this idea in our own model once it's loaded. So it takes quite a bit of time because the model is quite huge. Let's see. Oh, this is runway. These. Okay, it didn't quite get it right, but it got the idea that an astronaut is on the moon, right? So you can use the hosted inference here, but we will do it from our code shortly. So this is the file. This is the file. Okay, I think it's done. Fine. Awesome. So now let's come type our idea here. Okay. So sorry, are we still following? Are we together? Have we missed it anywhere? I can easily backtrack and touch on anything. Please just interrupt me if you're lost. Okay, fantastic. Right. So let's every time we run this, we're going to get a different image. That the last time I ran it, that's the image you saw there that came out. Every time you run it, you get a different image. So this is the inference happening, and we're saving it. Look at that. Look at that. Yeah. So I can run it again to give me another image. So this is This is us generating image. This is how all those models work. Even the DALI that is charging you, Mid Journey that is charging you, all of them. This is what they do behind the scenes, right? Like this another image, right? You can keep doing that or change the idea. Hold on, let me change the idea to what we have there. So you can play with this. You can play with this as well with on Google Colab. So we'll try to explain what is going on, shortly. Wow. Seems this guy doesn't know what the idea of an astronaut riding a horse on the moon should look like. He's missing out the horse part. This is exactly what we saw on Hugging Face as well. Surprisingly missing out the horse part on the Mars. Let's change it to Mars. On Mars. Okay, this is perfect. This is perfect. Got the context that okay, we're talking about Mars now. Mars is red, you know, so the soil looks red, and actually the astronaut is riding a horse, right? So the image contains some other things, but let's get back to the main thing. What is really going on? Guy able to how is this guy able to convert text to image, right? So we are converting data type from one uh, cardinality to another. Essentially, that's what we're doing here. And I opened up one image here. Imagine we trained a diffusion model based on these data sets, right? To say, hey, this is what sprites look like, gaming sprites. This is what they look like, and I ascribe some text to this. Let's say I call this, you know, Joy. This is Steven. Uh, this is Steven. This is Deborah. You know, or Israel eating something or whatever. Ascribe those texts, right? Those embeddings, and I trained the model based on these data sets. And I come after training to say, hey, generate an image of Deborah and Steven talking, right? As long as those text embedding exist in the data sets, we expect that the model should be able to do it. But how does that happen, right? So this is what it does. So I have a second image here. I have a second image here. So when you say that, okay, this is Israel the legend, right? If I ascribe that text, remember we had that here as well. Each of the images that we have has an accompanying text, has further information as well, has further information, the language, whether it's watermarked and all of that. So if we have that kind of, this is the first image. This is the main image. And during the training process, what a diffusion model does is that it adds noise to that image. This is the original image. So if I put up my own picture there, it will add noise to it. And it will keep doing that until, it is completely a random data that, I mean, it doesn't represent Bob anymore at this point. So the first time, definitely this is Bob, right? The second time, after adding a little bit of noise, it says, okay, probably this is Bob. Well, maybe this is Bob or Israel or Deborah. At a point that it is fully done, it is now, at a point where it doesn't have any idea whether this is, Bob or Israel or Joy or whoever, right? That means it is fully, the data set is fully, at that point, it's 100% noise. There's no signal available anymore. So during, still during training, what the model is going to be doing, can I reverse this noisy data back to Bob? And if I were to do that, can I predict the amount of noise that I will have to remove from this 100% noisy image to be able to, stepwisely work my way back to Bob? I don't know if this makes sense. So during training, you have a picture, high quality picture. I think we have a couple of them here. These brides and all that, colorful looking, people, and then these bottles. Sorry, these glasses. These are the pure images. During training, what the AI model is gonna do is to keep adding noise, like that TV, that 1990s TV, that's black and white, and when it's not tuned to any station, that blurry thing that you'll be looking at will just be dancing around the screen. That's where it wants to get to. Maybe with a little bit more colored, not that black and white. Okay, yes, I think color screen, all those colored TV with massive behind. I don't know. Do you guys remember those TVs? Let me see. Colored analog TV. Why? I can't see anything here. No, this is not what I'm looking for. But do you guys get something more like this? Something more like that. Nah, I'm not saying it. Yeah, so it's something more like this, but we colored, with all the RGB color right there. Something more like this, right? So we want to talk. We want to keep adding noise to a pure image each step at a time. And once we have full noise that we don't know what that image is all about anymore, we want to now, you know, remove those noise each time to get the original image back. So that once the AI model is able to do that correctly, at a point that it's able to do that, you can now give it, because it knows during the training, of course, the model will have access to this, right? The model will have access to the text, right? And it knows what it's trying to get back. So it knows that, okay, it's trying to get back this Masjid fundraising campaign dinner 11th May update, right? And this is what it looks like originally. It has added noise to it. It knows that, okay, right now I don't know this is Masjid fundraising campaign anymore, but I want to get back Masjid fundraising campaign dinner, right? And what I will do is that I will remove noise. I will remove noise from the no idea point, and steadily, the same way that I added noise to it, I should be able to get, an image back. So it will now do a computation to say that, hey, this is the original image before I added noise to it. This is the image I got back when I denoised it. How close are these images? Essentially, it's easy to do. Pixel one of the first image, look at the color, right? pixel 2 of the image, you look at the color, and then you compare. There's a numpy function to do that. You compare how far away they are, including distance of those two numbers. If they are too far away, it will realize that, okay, you know what, I need to adjust the training parameter and then go get at it again, and go through that process again, and keep doing that until the error is so low. Something is consistent across all these AI models. The importance of error to adjust the model, right? So he knows that, okay, you know what, I don't have to get it right the first time. In fact, it's never even possible that I'll get it right the first time, but I need to understand, how wrong I am in doing what I need to do. So in classification model, it is guessing, okay, is this cat or dog? If you misclassify something, you realize that, okay, you know what, that was a concept of confusion matrix, right? That Dr. Tulu took us through, right? And then in regression, it's going to, do all these root mean square error, and all these various error types to see that, okay, this is the answer that I'm supposed to get, but this is what I got. Now, an optimizer, we now look at, okay, how far the two information are far apart, and try to see that, okay, let me change this parameter in the weight or in the bias or whatever, and then it will do that again, compare, okay, this is the new answer that I got, what I'm looking for, still quite far apart, but a little bit better, right? And then you keep doing that until it gets so close as much as possible. So this is what happens. Oh, my network. Sorry, guys. Can you hear me now? I think I was disconnected for a bit.
Yes.
Okay. All right. So I was explaining the idea behind all these diffusion models and all that, right? So that is why you will now, at the point, once you have a model that is fully trained, you can now pass it a text prompt. We could still call it prompt this time as well. You pass it a text prompt, and then it generates an idea of what it thinks represents that particular image, right? So how does it do it? It starts from a pure noise image, from a pure noise like this. That's from a pure noise. And it knows that, this is the idea, that you're trying to get as a picture. Of course, that's been, the specific idea you're looking for may never have been trained, may never have been part of the training data set. But as long as bits and pieces of that is contained in that training data set, the model will be able to combine those ideas together and produce an outcome. For example, if the data set has avocado and the data set contains chair, you can ask it produce a chair looking avocado. Sorry, an avocado looking chair, whatever. I mean, so at the end of the day, because chair was reduced to a number during the training process. Avocado was reduced to a number during the training process. This is actually what creativity means for a computer, for AI models. It looks like they are creative, but at the end of the day, they are adding numbers and just subtracting numbers and manipulating all these vectors, right? So what a model will do is that, okay, because it has the vector representation of what a chair looks like, and it has a vector representation of what what a avocado looks like, it can combine those two ideas and print out an image that will be a chair looking avocado or avocado looking chair, whatever you want, right? So it will start from a pure noise and start denoising. At this time, you can be wrong or right because whatever it gives you is what it gives you. You can only be wrong, right or wrong during the training process, right? You can only be right or wrong during the training process when you have an objective truth to measure against. But now, during the inference, you use it like that, and they say, yeah, that's the creative machine. So, what makes machine creative essentially? Oh, I'm really struggling with my network today. I've tried the second one, yet it's still. Hold on. Can you hear me, please?
Yes.
Okay. But can you as well see my screen?
Yes.
Okay. All right. I thought I was gone again. All right. So, Joy, your question is, can it generate stuff based on training data? The answer to that is yes, it can. It can. You know, it can keep tweaking the vector that represents that particular data, and it will, be giving you new ideas, new ideas of that. Not only, Joy, not only, it is so flexible to create new ideas. Maybe my network was bad when I was trying to pass that across. It is so flexible to create new ideas. So I have it. Let um let me do this, right? Let me do this. Screen not shared. Oh, sorry. All right, you can see it now, right? Okay, cool, thanks. All right. So I was saying that if your training data set contains an example of avocado, it knows what avocado looks like. It knows the general, embeddings, vector that, when they say avocado, this is what the numbers look like, right? Now, if you say car, it knows the general, context in terms of those numbers, right? What they look like. You can now say a car that looks like an avocado. I mean, that's never contained in the data set. It will be able to do the vector manipulation of each of those data sets to be able to give you an idea that looks like a car that looks like an avocado. It's never in the data set, right? So that's the beauty of generative AI. And I've been talking about vectors a lot, so you can play with this, be changing the text as you like, keep changing the text and see what it gives you, you know. So I will change my Google Drive, Google Colab to, okay. So I have something here, say convert file to number, right? So I will upload a few things here. I'll upload a few files to this collab right here. I think I have some of them here already, by the way. Okay, so image. Okay, so let me. So you can also access this on the repository. So let me import all these guys and upload an image. Upload an image right here. I think it's image.j. Do I have anything like that? I think I should have something like this in my local computer. Okay, so I have an image of a fish here. I have an image of a fish here. Let me select that and upload. What did I do? Okay, so I want to upload this fish. I got it from Shutterstock, right? And I can run these to get okay. Excuse me, I think the path. Yeah, it's the path. It's complaining about the path. It's complaining about hold on. I think I'm not getting the path right. You know what? Let me put it in the sample data. Let me put it in the sample data and then run it. Okay, fantastic. So so sorry, guys. Can you hear me now? So sorry. The network is really not my friend today. Okay. All right. So what I did here was to generate a okay. Right here, I converted, this particular image to a number, right? I converted the image to a number. I printed it in, colored, gray, and then the shape, right? The shape of the data is, 213 by 237 by 3. The 3 here is because it is, you know, red, green, and blue. So the red we have, one by one. The green we have one by one. The blue we have a one by one, right? RGB. And then till the pixel 213 by 237. If we look at the image, how can I see the image dimension? Hold on. I think properties, Abby. Get info, yeah. So yeah, can you see it? The image dimension is 237 by 213 pixel, right? That means each pixel representing each number. So that is why the shape is this way. And of course, the grayscale is because it's only black and white, right? So it's either, you don't have a multi-dimensional, these three axes to it. That's the point I'm trying to make. So this number represents that fish in grayscale, and this number represents, I think I saved it. Okay, I saved it in a CSV. It's quite huge. I don't think it will be able to show that. To be quite huge. It may not be able to show us the CSV. Let's see if it will. There's a lot of numbers in there, right? So that number represents the fish. Oh, fantastic. This is the fish you're looking at. So let's see. Okay, it's showing us top 50, right? So that means this guy, the picture has a lot of white. That's why you're seeing 255, 255, right? If you recall, it has a lot of white around it. So there's a lot of 255, you know, there's a lot of 255. Show 100 per page. All right. So this is, I can upload another image that is not, that doesn't have a lot of white so that we can just see, right? But point is, this particular number set represents that fish. If I upload another fish, I can do a, numpy expression that will just look at the number and find out the similarity. This is not machine learning yet. This is just classical, mathematics. This is just classical mathematics, right? So the numbers represent the fish. The machine is learning from the number to recognize what the fish looks like. Now, we now tell the machine to say that, okay, give me a fish that looks like a human being. So the machine knows generally, of course, it won't be one, right? There will be a number distribution that it knows. Like, okay, if it is not this, it will be this, it will be, this is the variation, right? Based on what it has learned, right? And then it knows what human being also looks like, a distribution of what human beings. Of course, it will not be one, right? So we know that, there's a black, human being. There is, we have yellow, white, red, different types, and then different hair colors. And this is what is called latent space. So it's taking, it's extracting small information from those, data sets and learning something unique about it. If you know that, okay, broadly speaking, this is a fish, but there is, a latent attribute to this particular fish type that is seen in the other fish. So it could know that, right? But it knows that this is a fish. So now I now say that, show me a fish related to human being at the, creative layer of the AI model. It will be able to, essentially do some sort of, adjustments to these numbers to then print out the number, and then we can convert the number. To convert a number to image is pretty straightforward and easy. I think I added one here. Yeah, there's a number, there's a numpy. We'll probably just do that shortly. I can convert this CSV right back to that image, original image, just these numbers. Numpy will easily do that for us, right? So the same way we have that for okay, I think I should have this in MPT in my download as well. Let me see. Okay, I do. Let me upload it. We've been talking about images so far, but the same concept applies to audio, right? The same concept, everything we're talking about images as well applies to audio. So we want to extract, so what is happening in this code? Let me put it as well in okay, sample data audio. Let me just remove this audio, right? Okay. So essentially, what is in that audio? Let me play the audio. Oh, you guys might not be able to hear it. Did you guys hear it? No. No. Okay. Can I share audio here? No, I don't think so. Yeah, but it's a very short. It's a very short audio. It's about how many seconds? Yeah, it's a really short audio. So here there are lots of ways to handle audio. One way is what Dr. Tolu showed us the last class, where you can do you know frequency spectrogram, right? But there are a whole lot of ways. Here in this line, we are loading the audio file. We're referencing the path to the audio file. We are loading the audio file with this method. It's a touch audio dot load, and we are trying to get the original sample rate. It is important because all the biggest information in audio is in the frequency, right? So even if we're not taking a picture of the frequency space, we are still having to deal with the frequency in one way, shape, or form, right? Because that is where the information about the audio content is contained, right? As I'm speaking, the frequency is changing, right? And even though my voice is different from Dr. Tolu's voice, and it's different from Deborah's voice, and Joy's voice, and Stephen's voice, right? But you could still understand what I'm saying. So the differences within our voices is essentially, what is contained in the latent information, but the general broad understanding of, when we say ABC, is this the same, right? So what we're trying to do here is to now resample, because if you don't resample this audio, right, to a frequency form that you can deal with, you will have a malformed frequency. Okay, so let's say the audio was created with a frequency of 1000 hertz. I don't know the frequency of my voice, by the way. I don't know. Let's just assume it's 1000 hertz. But I'm now trying to do training on that voice data. I'm now using something else. Let's say I'm using 2000 hertz or 20,000 hertz. There will be some words. You may get some words correctly, but there will be some words that will be so close, at that new frequency space, essentially increasing the error rate, the likelihood for error. So if you don't want to, deal in that frequency space, it is better to convert the original audio data to a new frequency space. So what I'm doing here is essentially taking the original frequency data, I took that from here. Immediately I loaded the audio and I got the frequency. I can print that actually, So this is the original frequency. I'm converting it to 16 hertz because I'm trying to use a feature extractor that has been trained on 16 hertz frequency. The reason why I'm going through all of this is because someone has done all the hard work for me. I don't have to take a picture. I don't have to run all the some smart guys in Facebook. They've done this model that can extract features from frequency and give me the number representation of of those words, right? But they built it in 16,000 hertz. They built the model. This is the model right here. You can find it on Facebook's. You can find it on Facebook's. Okay, fantastic. Wave to Vec. Right. So this is it. Wave to Vec. The base model pre-trained and fine-tuned on 960 hours. You can find this data set as well on the hub. So on 16 kilohertz sampled speech audio, right? So the audio that I'm uploading, if it's not in 16 kilohertz, I have to convert it to 16 kilohertz so that it will be able to fully, convert the frequency space to the right number, right? So when using this model, make sure that your speech input is all fantastic. They even put it there. When you're using this model, make sure that you convert your input speech to 16 kilohertz, and then they attach the research paper if you want to read it, and then the abstract and all that, yada yada. Right? So that's why I had to do that. So I had to convert it to let me print the original sample rate. Okay, let's see. All right, so can you see the original sample rate was 44 kilohertz, 44.1 kilohertz, right? But the Facebook feature extractor model was built on 16K. So that mismatch, you know, it's like when you're traveling, this happens a lot in Nigerian airports. All those ladies that will be announcing body boarding announcements, this is to tell you that flights, Air Peace Airline is going to be. If you are not, listening, who has experienced this before? If you're not listening hard, you will miss your flight because I don't know, those ladies don't like to speak within the natural audible frequency. They just kind of like change their voice. Especially, I don't know if that's how it is in the American airports as well. But this happens a lot in our Nigerian airports, especially the one in Lagos here, right? So similarly, someone listening to you, someone that has been trained to hear audible speech, that's now listening to someone that is speaking differently, even though the word I may know the words that is being spoken, but I won't be able to pick it correctly. So that's why the conversion is necessary. I think I've spent so much time there. Essentially, what this guy does, we are taking this from it's a module from Transformer. So there's a transformer module. We loaded the wave to vec feature extractor. Essentially, at the bottom line of what I'm trying to say is that we still converted the audio to numbers. This is the number for the audio, -2, whatever, and then it's a bunch of numbers. It's about that few seconds audio contains 51,000 numbers in 2 dimensions. So this is the shape, right? So 1 by 2 by 51,131. But these are the numbers that represent the information contained in that audio. So if I train an AI model based on these numbers, let's say, different variation, different voices, different, all types of different things, say, okay, this is how to say door. So all this is door. But, door from all different sets of people, there would be some sort of pattern that would be consistent in the frequency, how the frequency moves, and that would have been captured in the data. The machine will be able to learn that okay, this is the frequency pattern that that's for door. But yes, there is subtle difference. There are subtle differences in terms of okay, how this sounds. Of course, that's why the numbers will be different. The numbers will never be the same, right? But it will be able to capture the general pattern contained there. So lastly, this is words. This is for words. This is taking us back to I think this is lesson 2. Everything, you have to be able to convert everything to numbers before you can do anything with it in terms of machine learning. That's machine learning related, right? You have to be able to convert everything to number. We've converted the image to number. We did the image parts a lot during the, image classification stuff. But there are a lot of models have a lot of libraries have abstracted this thing away from you, that you don't know what is happening behind the scenes, like all those auto ML thing that Dr. Tolu showed us. They've these things are nested way deep inside those libraries. But I'm trying to bring this out so that we can understand what is happening, and then because this is mostly important because of the fact that to understand the efficient models, some of these things might be important actually, right? So that's why we're going back to them, right? So everything has to be able to, you have to be able to get everything right back to numbers. Similarly, words, right? You have to convert them back to numbers, right? The word embeddings. So these words, convert these three words. Sorry, are we still together? Hello?
Yes.
All right,
Yes.
thank you. Thank you so much. All right. So again, for words, there are a bunch of ways to convert them to numbers. There are a bunch of ways. You know, what you can build your own NLP models by yourself. You can do all those things by yourself and and have fun if you want to, right? But again, similarly, the way we stole this model from Facebook, we didn't steal it, by the way. I'm just kidding. With the way we leverage this model, the thing is that you want to be productive, right? You don't want to do the work that someone else has already done again. You want to go to application as fast as you can, right? That's why we leverage this Facebook's model to actually convert audio to numbers is a whole lot of work. Is a whole lot of work. And this guy just gave us in one line of code, right? So who are we not to use it? Who are we not to use it? What is the significance of first converting things to numbers? Because that is where the information is. Deborah, that's where the information is. That is everything that you are producing as human, whether it is your artwork or the books that you have published, the words that you say contain some sort of intelligence about you, and it is impossible for those for those intelligent properties to be transferred to a computer just like that. So we have to convert them to a number so that we can now find the pattern within those numbers. Remember class, I don't remember the number of class, yeah, but class maybe 2 or 3. Everything has to be numbers, and then we now find the pattern within the number. Yes, the thing is that most of the modern libraries have abstracted these things away from us. They've abstracted this thing away from us. But for us to be able to function at some level, we would need to just go back to the basics. And this is the basics. This is the bottom of everything. Every model that will ever be built, we have some error function. How can I calculate error? How can I know I'm wrong? Now that I realize I'm wrong, how can I change back my retract my steps? All the models, the way they do it is different. The way they all do it is different, but it is a general concept across even diffusion, transformer, units, all of them. They share that same commonality. That's the basics, right? So it's all based on numbers. It's all based on numbers. So again, to quickly do for text. So I'm leveraging this model. It also can be found on the hub. I think it should be on Kaggle as well. Most of these models are now on Kaggle as well. The point is, don't do any work that has been done before. Get to your own application and do whatever you need to do. So pre-trained model on English language. So all the English words that exist, this guy knows it. If I want to do my own, I will probably just, get a few books here and there and, convert them to numbers. Remember from class 2, what this guy does is that it's a dictionary. He creates a dictionary and say that for me, anytime I see book, I will ascribe 2 to it. Anytime I see car, I will ascribe 3 to it. Anytime I see this word, I will ascribe this number to it. So that means every word in the dictionary has its own number. And what he's looking for when you're doing NLP task, you're looking for the pattern of intelligence in the way the words are structured. But you can do that with text, but it's easier to do that with numbers, right? So, instead of you gathering all the gathering dictionary and all those things, someone has done it for English language, right? And then says that, okay, gives you instruction. If you want to use it, this is how you use it, right? So they have for English, they have for Chinese and all those things. So if you want to convert them to numbers, you simply just pass in your words, and then we imported tokenizer from transformer. Look at it up here. Yes, Deborah, very good point. Very, very good point. There's an NLP model that uses characters and numbers. There's one like, but it is not. Do you know why? Can you guess why it's not performant? Who can guess? Yeah, that's one. That's one. So there are three types. There are three types. There is one that does what you said, uses characters A, B, C, D, E. So it has a full breadth of about 50 something. By the time you add the special characters and numbers, about 50, less than 60. Information in its dictionary. There is one that converts each word to numbers. There is one that now converts tokens. Like when I say Israel can be broken down into like two syllables, right? So it will ascribe a different number to the first part of the syllable, a different number to the second part of the syllable. That is the most performant today. Really, I must be sincere with you. Nobody knows why, but people like Dr. Tolu, that's why they are paid a lot of money. They are there to do a lot of research and find out what works best. There are ideas on why it works best. Number one is because, for example, if I say transformation, if I ascribe transformation and I put the word 58 is the number ascribed to transformation, that would work fine. But the model, we don't know that there is relationship between the word transform and transformation. So what we've observed is that by breaking words down into tokens, models are able to find patterns between. Sorry, can you still hear me? Hello?
Yes, we can.
Okay. So what we found is that by breaking words into tokens, models can find pattern between words that are similar. So it will know that there's a relationship between transform and transformation. It could know that, okay, transformation is the noun form of the verb text transfiguration, and all those kind of words that have different forms. So by breaking it down into tokens, it can find better pattern. But you see the character based, just it performs so poorly because there's limited information on what it can learn. There's limited information on what it can learn. So it is better to, if you cannot do word based, do token based. So most of these models we are leveraging here have, they are mostly based on, token. That's why we are importing tokenizer we imported tokenizer from transformer. We pass the model name and then we pass the word, right? So it's going to convert these words to numbers for us, right? So this is the word. Let's see how many characters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15. 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. That dot could be for 1, right? The dot. It's just ascribe a number to it as well. So converts, it has just successfully converted the whole text into numbers, right? So by the time I do a numpy dot product, and then I write a similar word that is contextually similar to these. Hi, Deborah, you want to say something?
Yeah, I was gonna ask if it randomly assigns numbers or if it's kind of like he uses like hexadecimals or ASCII to assign numbers, or is there a pattern to it, sort of?
There is definitely a pattern to it. It's not random in any way. It's not random. So each tokenizer has a specific way it does its own thing, right? So this model name is based on. I don't want to go back to the very basics of us building our own NLP from scratch. But if we were to do that, what we would have to do is to ascribe those numbers based on the problem at hand. But these guys have ascribed the numbers based on all the word in an English dictionary. So if we are trying to tokenize, right, we might as well just use that. So by the time I say convert, if I say convert, right, what I will see is probably 101, 101, 101, 101. So in this guy's dictionary, 101 is probably for convert. I don't know how he does that, right? This 10, 10, 463. But you touched on something about hexadecimal stuff. Different models have different approaches. Some are bytes based. While scientists like Dr. Tolu, they were trying to find the most performant way to actually tokenize. So there've been a lot of experiments on different ways that includes, actually instead of doing it based on literal numbers, can we do it based on bytes? Can we do it based on hexadecimals? But at the end of the day, what you still end up with is an information about a number and some sort of complex data structure, whether it's a word, whether it's a byte, whether it's an hexadecimal. But the point is they are not random at all. There's a pattern to the way it generates or ascribes number to them. Does that make sense?
I see. Thank you. Yes, it does.
All right, thanks. So the reason why we had to go back to the basics here is that that is the foundation of generative AI, and we can write different words. We can write different words that are contextually similar, and then use NumPy to see how close these words are. They literally mean different things if you look at the text and the words, but semantically they are similar, right? Because the numbers actually hold the meaning. That if they don't converge that way, that means the numbers that we are seeing don't represent any information based on the data set that we have. What we want to do is to ensure that the data set that we have has as much information density of the data that we are feeding in. The more information density that is contained, the better. That's how the model will be able to learn, right? So let me, quickly go to a particular audio. Let me open this one. Hold on. Okay. Okay, I have a very interesting demo collab for you here for you to check out. You can play with it in your leisure. Let me quickly demo. It's audio based. Let me see another one. Okay. So I just want to show you this model so you can, have fun with it. It's also generative. Um, the goal of this class is just for you, it's just like an introduction to generative AI. In image terms, we use diffusers. In words, if it's words based, transformer, we use transformer, based on all those libraries that you've seen, right? In uh, you know, let's say what are the type audio, we can use a bunch of those as well. Diffusers work fine, and there are some specialized approaches for that as well. So this is a model. This model is called back. Okay, let me open this one as well. MMTS. Okay, AI voice. Let me open this as well. All right. You guys will have a lot of fun using this model. You can check it out on Hugging Face. I'm not sure if it's on Kaggle yet, uh, but you can check out the model on Hugging Face. So I'm loading the model. What it does is that it converts text to audio. What we saw earlier was text to image, right? That was text to image, but this is text to audio. Okay, let's say, hello, my name is Stephen, and I like learning about artificial intelligence. But I also have other interests like swimming, like swimming. So next week we're going to build a sample model from the scratch, from the ground up. We'll probably just do that. So if we want to go, so deep into generative AI, the next 12 weeks is insufficient. So what we'll just be doing is to, give you enough background, that will help you find a lot of footing. Generative AI doesn't have so much application in industry yet. What, Dr. Tulu took you through is essentially what you would do in most AI or machine learning related jobs that you have. You know, only very few companies have been able to productize generative AI like Runway ML, like OpenAI, ChatGPT. Very few companies. So except you find yourself working in those places, that is when you would actually, need to leverage, generative AI models like diffusers and transformers. So, but it is very useful information to have or skill to have as well, especially if you have fun projects to execute with it. There's a lot of things that is possible with this kind of models. I can think of applications in education, application in support, customer support, application in, eh, it's limitless. It's limitless, right? All right. So I think this is done. So yeah. So all I'm simply doing again, sample rate is pretty important. It has to be close to the sample rate of what the guy was trained on, and then we want to generate audio, and we preload the models. and we can pass text prompts to generate audio. It's very simple. So it has a generate audio function, and then we pass this text. So text, if you remember that lesson with Dr. Otolo, where different data types. So this is a string, right? So adding these three codes allows you to be able to do multi-line string, right? And it won't break. So we pass that, and then we have an audio. Let's do this. Let me try to disconnect my AirPod. Maybe you'll be able to hear. Hello? Hi. Oh, you can't hear the audio. Wow. Oh, God. This dude, get out of my way. Hello? I'm trying to drop the audio for us. Let me drop it. Let me drop it here. Uh, yeah, that's what we just generated. You can listen to it. Try to play it and listen to it. That's what we just generated right here, using Back. So Back is one of the interesting generative models already pre-trained. Uh, I think it's pre-trained on a couple of languages. So let's check. Okay, let's check it out right here. If you need to build an application that will leverage generative AI, all you have to do is just to write those codes that we have um, in the Google Colab, and you're good to go, right? So it's within transformer model as well. Yeah. Okay. Cool. So next week we will get into the details of what is inside a transformer model. What's happening inside a transformer model? Okay, that's pretty good, right? You've listened to it. right? That's pretty good. Now, lastly, the last demo I want to do, this is also added in our Google Colab. Sounds very natural, very interesting. Yeah, so the last one that I would do is to use this generative AI model. This was built by Meta, the Facebook team. Um, can you tell it to speak in a female voice? Definitely. Let's do that. Let's do that. So, uh, woman. All I just need to do is to change this to woman and run it again. Interesting Yoruba. So we're going to do something in Yoruba now. We're going to do something in Yoruba now. You will give me a few more minutes so that we can cover all the demos. So this is just to immerse you fully in, what is generative AI, what their capabilities are, what they can do. We've talked about, how the conceptual understanding of how they do these things. Because if they can tell you that if they can classify information for you, tell you that, okay, what you just said is dog, what you just said is cat, what you just said is dog, why can't they say it back to you? That's where we started from. So for image, we keep adding noise, until we cannot tell that, until we cannot even have an understanding of the original image compared to what we now have, because it's so noisy, and we will now denoise it right back. So that's the approach for image, right? Similarly to words, you keep adding noise, and then at the end of the day, after removing the noise, you check, okay, am I able to correctly find my way back? So that's the approach at the end of the day. So for text, it's a little bit different for text. So for text, it's using something called encoder decoder model. So these things, this is the AI terrain. There are no walls. People are thinking all the time to find approaches that help machine learn. At the end of the day, the ultimate goal is that how can we make these machines learn? How can we encode the information that has high information and let the computer to be able to, decode it to, okay, this is the information that is contained in this data, and let the computer to be able to reproduce that information. That is all that is happening. So there are different approaches. And if you look, we won't get to it today. If you look at the repository, there are lots of things like DDPM, DDIM, DD. Those are different techniques. DDPM means DDPM means denoising. It's a denoising technique that is, probabilistic. It's a probabilistic denoising technique. Is you say that, okay, what is the probability that I'm right by guessing how much noise was added in the first place? By the time it's working its way backward, there's an image I have here, UNet. So a popular model for image is called UNet. So this is how it looks like. So this was originally invented for something else, but it has been, used a lot for, generative AIs. So can you still see my screen? Can you still see my screen? Okay, fantastic. So this is what happens during the noisy adding noise. This is what happens. This is the step. It's a convolutional neural network, the same convolutional neural network that Dr. Tolu taught you guys 2 3 weeks ago, right? Adding noise to it, but it still has the information of the original image, right? This line means the original image before adding noise. This line means original image after adding a little bit of noise. You know, this one means image after adding two-step noise. This is the noisiest image. This is the noisiest one, right? You can't you can even find a connection between this and this at this point. Now this is the denoising part. It will now predict, because it knows the original image. Because of this thing, it knows the original image at step 0, it knows the original image at step 1, it knows the original image at step 2, it knows the image at step 3. It will now predict how much noise was added between this step and this step. It will predict how much noise was added between this step and this step, and compare it with, because it has the information, right? And it will keep doing that until it gets so close, and then do that for this as well. How much noise was added between this step and this step, right? It has the reference of this ear of the truth, of the ground truth, right here, right? Same thing until it's able to reproduce the original image right here. This is the output. So it was originally done for this technique was used for image segmentation back in the days, around 2014-15, but has strong application in generative AI, right? So that's the technique. This approach is kind of like novel, like kind of different, but it gets the job done. So that's the point, that at the end of the day, you are passing information to the computer. And so don't be hung up on the framework, or on the technique, or on the method. With a very strong basis, you will be able to adapt and generalize on any machine learning task possible, right? The reason why they call it unit is because of the shape. Is U, denoising, not adding noise layer, and then denoising layer, so it looks like U until it's able to get the original image right back. So let's go back and do something. Okay, hold on. So let's, pardon me, I think I'm always late. Dr. Tulu is never late, right? He was never late during his classes. Okay. All right. So I think I'm trying to get this guy to produce a female voice. So their documentation says that it can add laughter, laughs, sighs, music, gasp, clear throat. Let's change it to clear throat. Let's change it to clear throat. So, and it can generate in English, German, Spanish, French. I mean, pretty much all the languages. This one doesn't contain Yoruba, so we can use Yoruba here. Um, all right. Where am I? Okay. All right. So that's the female voice. That's the female voice right there. You can listen to it. I think it's pretty good as well. So now let's do one for Yoruba, right? Let's do one for Yoruba. So the reason why we can do this for Yoruba is obvious. We can use back model for Yoruba because it wasn't trained on any Yoruba, um, you know, audio. It wasn't trained on any Yoruba audio. It was trained on all these languages instead. Okay, I think I opened it here already. English, German, Spanish, French, and all these languages, right? But here is one that was trained on Yoruba. It was built by Facebook. This was built by Facebook. So this repository contains a collection of text-to-speech models offering support for over 1,000 languages, which includes Pidgin English and Yoruba and Hausa. These models are part of Facebook massively multilingual speech project. So this is the Google Collab here for Meta MMS demo. I think I've already run this. So how it works, the code is pretty simple. The code is pretty simple. You can see all the languages that's supported. If you click this link, you'll see all the languages supported by Meta's AI. You will see, if you type Yoruba, can you see? This is Yoruba right here, and this is the language code. Let's see, Hausa. Can you see? Hausa, HAU is the language code. Pidgin. There are a lot of Pidgin, but Nigerian Pidgin English is one. This is the language code, PCM. Let's do something in Pidgin English real quick. So I've already loaded the Pidgin English one. Can you see? So I'm simply loading the model file. I'm loading the model weight from their, FB, Facebook AI public files. So there's a site that Facebook keeps where all their models, public models, are stored, right? And then I'm saving it in the local directory here. Once it's done, you'll see pcm.tar.gz right here. So I've downloaded the model for Pidgin English, right? I can do the same for Yoruba. Let me do for Yoruba as well, so we can quickly demo that as well. I think Yoruba language code is YOR. So to do that, just change the PCM to YOR and then YOR right here. Let me confirm. Yoruba, yeah, YOR. Let me load that again. So I'm downloading the model files for Yoruba and for Pidgin English. So I should have two zip files. Sorry, am I still audible? I need to check. Okay, this is my network. All right. So I've loaded the model file for Yoruba. Sorry, my system is slow. Let me quickly plug it. Didn't realize. All right. So next thing, let me just run this part. So I'm trying to unzip it. So I will unzip the two of them. So I will unzip them into the data folder, right? That's what this line of code is doing. It's the exclamation mark, I think Dr. Tulu explained the other day, it's not a Python code, it's a terminal command, right? That's why we're adding exclamation mark. So we're making the directory data and then we're unzipping. So if you come here, you should see data and then you can see PCM and then Yoruba. So those are the model weights and files for the two languages, right? So now we import the library that Facebook released. Okay. Sorry, let me get my charger real quick. Give me a second. All right, sorry for the broken transmission. I'm back. We should be rounding up real soon. So now all I have to do, once I've loaded the model, I have to then do this, right? So I'm importing the lang code. Let me import for both Yoruba and import for both Yoruba and Pidgin English. All right. So I'll run this. So that's what we're doing. We're loading the Yoruba and Pidgin English model. So fully done. So I will then type whatever Pidgin English I want to speak out. You know, make you know, say I love you, where, uh-huh. And then convert it to voice. Oh, sorry. TTS Yoruba, Yoruba, TTS Pidgin. Sorry, I made a mistake in this code here. So I have to do it like this. All right. Okay. Okay. Interesting. You guys need to hear this. Wait, I can download this. Wow. I can download it. Let me record it. Let me record it for you guys. I don't know why I can't download this. I just recorded it for you guys. You can play it. I can download it and share it like unlike the other one. Right? So let's do for Yoruba as well. Let's do for Yoruba as well. So I'll just copy all these codes. Change. No. Stop. Change the TTS Yoruba because we loaded the TTS for Yoruba inside this variable, right? So we have to pass that here. TTS Yoruba dot synthesize and then put the Yoruba words here. Can someone give us a Yoruba sentence? Did we get did we get this notebook from Meta or sorry, I'm not sure I understand your question.
So I was
Okay.
asking, is the notebook in the documentation, or is this something you wrote yourself? The notebook you're using for
Yeah,
what?
it's I've adjusted it. I've
Okay,
adjusted it a lot. But yes, it's from it's a popular library on the internet.
okay.
Yeah. It's I think it's from this account, this GitHub account. Wana Hong. Let me see. That's the original author of the notebook, CTMS. So the library, yeah, that's it. That's it. This is the GitHub account. So you can check out this GitHub account as well. But if for you to get a TTMS model itself, the TTMS model is sorry, give me a second. Okay, fantastic. Where was I? So, what this guy just did is to create an adaptation for Facebook's model. Sorry, watch. What it did was just to create an adaptation for Facebook model. So the Facebook's model is right here. I think I just opened it right. So it just created a, you know, I mean, there's no the hard work has already been done by Facebook. We didn't build the model, leveraging and leveraging the model essentially. So it just kind of like created a support language support file, so that because it's not popularly, publicly available by Facebook didn't make that available on the repository. It's not anywhere. I don't think it's anywhere on the repository. So it kind of like made it a lot more user friendly to use, making all the support lists and all those other content available. But yes, okay. Someone gave us some Yoruba words to try. Babami no omomi. Did I speak that right? Bami no mommy. Okay, Bami no mommy. Oh, they no more. All right. So it's pretty simple to use, and pretty straightforward. The training and all we're doing right now is just doing inference. Facebook has already done the training, and you can use this guy's GitHub to get all the language that's supported. Do for Hausa, do for other local languages that you have. Wana Pong has really helped out to make that easy to consume. All right. No, this one is not good. This one is not good at all. All right, so that's what this guy is saying. It's so close. It's so close. So for us to essentially, take this forward, if you want, deploy this kind of language to, production, all you need to do is to get this language model trained by Facebook, the Yoruba or the Pidgin, and then use a whole lot of recordings, audio recordings of in English to fine tune it, right? We'll probably do a few things around that, if time will allow us, right? So to fine tune it, so to be able to speak better, we have more audio in English than in Yoruba, right? So it was trained on how many hours? A few. Yeah, okay. I don't think it's stated here. I don't think it's stated here. But if you read the research paper, it's I think it's there. 1,000 hours of audio for most languages, and that's why for English, I think everybody would agree that it speaks well. But for other languages, they just scrap, get as much data that it can use to train. But it is available for you to also fine tune, get a lot of audio to train it with, and then it will improve and be better. Yeah. So that's it. That's it right there. This is also available in the GitHub repository. You can explore and then make use of it, and then try other things out. All right. Thank you so much. Let's take questions from for now. We should be rounding up in a few minutes. Questions. Do you think you have a better introduction or understanding of, or a better understanding of generative AI and its application? We touched on image, audio, and what else? Yeah, image and audio mostly. We've not gotten to text, but we just did how all of them convert to numbers. Do you have any question? What's confusing? What's the most confusing part? Are you confused by any part of the lesson? Can we do text completion then to audio? Absolutely. For text completion, we will get to that next week. We'll get to that next week. We only brushed on transformer. We didn't really get it deep into transformer. For text completion, you would need an encoder model or an encoder plus decoder model, and then use either of these models here back. You know, I like how back speaks. Or you can use back model to this is a language actually from Wikipedia. I don't know what it means, but it happens to speak it well. You know, so Bach speaks smoothly, right? You just import it in your code, and then after text completion is done, you can build your own Siri. Nothing stops you from building your own Siri. You can build your own Google AI or Google Voice, or I don't know what they call it, right? You can there's nothing stopping you from here. Just from the inference, all these models are available for you to leverage. So yes, but yes, the text completion we'll get into that shortly on the transformer model part. Questions, 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 questions. No questions. Okay, thank you so much. It's a pleasure having you in class today. Next class would be getting it, deep into transformer architecture, talking about encoder and decoder architecture, and solving a few problems. Text completion aspect, and text generation aspect. For the For text completion, you don't need the decoder aspect. You can just do that from the encoder model is sufficient. But for the text generation like ChatGPT, you need the decoder module of the transformer stuff. So we'll be doing some stuff around that. And then we will be building our own diffuser model from scratch. We'll be building our diffuser model from scratch using the popular DDPM, using the probabilistic method, and just playing around the domain of generative AI. Thank you so much for joining today. uh, you want us to create vector databases. I don't think time will allow us. Time may not allow us to get there, but there are a bunch of vector databases. So a vector database, yeah, let's see. Hopefully, let's see. Let's say never. Never say never. But I'm not sure time will allow us. We are rounding up. We have two more classes, and the last class is an extension. This is supposed to be 12 weeks lesson, but we're making it 13 weeks, and we hope it to be worth everybody's while. So we don't want to make it excessively long, but not to worry. You will have all the knowledge, all the information you would need to be able to uh, you know, strike out on your own and explore the terrain of generative AI, which is, very new and evolving as well. Thank you so much. So, without any other question, Dr. Tulu, do you have a word or two to say?
Hello. I just want
Hello.
to say The class was very insightful. It was good. I picked up some things too from the class, and I just want to encourage everyone to keep working, keep redoing everything we've done in class, we've touched on in class, and then practice and practice. And like I said, we are building AI titans from Africa. So, and I hope at the end of, at least in the next 14 days, we shall have something worth it. Thank you very much.
Thank you, doctor. See you next class. Let's talk more. I want us to play with these models. I think we shared one on convolutional, sorry, stable diffusion. Try to change the model. Try to change the model to any other model types that is allowed, and show us the image that you generate. Share with us on Telegram, right? Also play with the massive AI model from Facebook, and you know send us what you have from here as well, and let's have fun playing with generative AI models. Thanks. Have a good evening, everybody. Bye.
Bye.